Okay, hello everyone. So today I will be going over a few problems in free fall. First problem. Luke drops a pile of roof shingles from the top of a roof located 8.52 meters above the ground. Determine the time required for the shingles to reach the ground. Okay, so let's encircle some important items here. First, drops. Second, 8.52 meters. Third is time required. Okay, so based on that, when we put our given and required, which we can combine in a sketch, drops tells us that you are observing the first case of free fall, which is an object dropped from rest. It's just simply dropped. And in that case, we already know that initial velocity will be equal to 0. And we also know that gravity or acceleration due to gravity is negative 9.8 meters per second squared. Okay? Now, the top of a roof is located 8.52 meters above the ground. So delta y is 8.52. However, because remember you're going down, okay? And going down means you're going in the negative direction. Therefore, delta y would be negative. Determine the time required. Okay? So, what do you have? You have vi, you have delta y, you have a, and you're looking for t. Which equation should we then use? Okay, so the one equation that has all of those values would be delta y is equal to vit plus 1 half at squared. Why? Because if you check, we have delta y, vi is given, we know that, and it's 0. A is something we know, and t is something we're solving for. We can play around with the equation then in our solution. So it will become 2 times delta y is equal to 1 half, or sorry, at squared rather. Okay, and then we can transfer a to the other side. 2 delta y over a is equal to t squared. Get the square root of both sides. You're going to get square root of 2 delta y over a is equal to t, which is something we've used very often in reaction time, in hang time, etc. Okay, so 2 delta y over a is equal to t. Now, let's plug in the values. So, 2 times delta y. What's delta y? Delta y is negative 8.52 meters. Acceleration is negative 9.8 meters per second squared. Okay? So in terms of units, this one will cancel out. But in terms of values, let's get my calculator real quick. So, the square root of the fraction 2 times negative 8.52 all over negative 9.8 gives me the value of 1.31862. So the value is t would then be equal to 1.318626 and so on. But what do we do for significant figures? Well, we do not count the 9.8 because this is a constant. Okay? What we're going to count would be this measured value. And this is 3 significant figures. So, when we then get the final answer, it will be t is equal to 1.32 seconds. Okay? So this is an example of case 1. Object dropped from rest. Okay? Now let's go on to another case. Case 2. After conceding a goal, Coach Chris throws his water bottle to the ground in disgust at a rate of 13.5 meters per second. If the bottle fell for 1.5 meters, calculate the final velocity. Okay, he throws his water bottle ground in disgust. This is case 2. Object thrown down with initial negative velocity. Why initial negative? Because you're initially going down, okay? Going down means you're going in the negative direction. That means a negative velocity. So, Consiglio throws his water bottle to the ground, so going down, in disgust at a rate of 13.5 meters per second. If the bottle fell for 1.5 meters, calculate the final velocity. So, given and required, let's make that a sketch. So the sketch would be that he throws his water bottle to the ground in disgust. Okay? So, in this kind of thing, we are given that the rate at which he does it initially is 13.5 meters per second. It fell for a delta y of 1.5 meters. And take note, this would be negative because you're going down, and this is also negative because you're going down. Okay? Now, in this case, what else do we know? Well, we know VI, we know delta y. We're looking for VF, and we know your acceleration due to gravity is negative 9.8 meters per second squared. So based on this scenario, what equation do we use? Well, the one equation that has all of those would then be VF squared is equal to VI squared plus 2A delta y. Okay? This one, we're looking for VF rather. VI, we have. A, we know. Delta y, given. We can solve for VF. So, this is actually much simpler to tinker about. So, VF would just be the square root of the entire right side of your equation. Okay? And when you get that, plug in the values. So, VI is negative 13.5 meters per second, square the entire thing, plus 2 times negative 9.8 meters per second squared, times negative 1.50 meters. Okay? So if we get our calculator and plug this in real quick, so that's negative 13.5 squared plus 2 times negative 9.8 times negative 1.50 gives us a value of 14.5481 meters. Okay, so VF would then be 14.54819,576 meters per second. Why is it meters per second? Because if you get the units, it will be the square root of meters squared over seconds squared, or simply meters per second. Now, what direction is it then? Well, we know that if we're getting the square root, you could actually be positive or negative. Remember? Because when you're squaring a negative, it also becomes positive. So, this one, we know that the direction is going down, therefore, it is in the negative direction. Okay, so this is your solution. And when you get to your answer stage, how many sig figs? We have 3 sig figs. We have 3 sig figs. This one doesn't count. Therefore, our final answer must also have 3 sig figs. Final velocity is equal to negative 14.5 meters per second. Okay, so that is case 2. An object thrown down with an initial negative velocity. Now, let's go on to the third case. Case 3. Object thrown up with initial positive velocity. Okay, Rex throws his mother's crystal vase vertically upwards with an initial velocity of 26.2 meters per second. Determine the height to which the vase will rise. I don't know why you would do that in real life. Must be angry at something, but anyway, let's check again. Given and required. Let's make it a sketch. So, Rex throws his mother's crystal vase vertically upwards. Throws it vertically upwards with an initial velocity of 26.2 meters per second. And remember, you're going up, therefore this is a positive velocity. Determine the height, so you're looking for the height to which the vase will rise, and that's it. Okay? But what do you know? In case 3, like a basketball, when you have a jump ball in basketball, at the very top of your flight, you know that the final velocity would equal 0. Okay? And your acceleration due to gravity would then be negative 9.8 meters per second squared. Okay, so based on these variables, what equation can we use? Well, we have the classic equation, Vf squared is equal to Vi squared plus 2a delta y. Okay, let's check. We have Vf, yes, equal to 0. Vi, something we have. A is something that we have. And delta y is something we're looking for. With just one unknown, you can then solve. Okay, let's transfer. We're looking for delta y, so let's transfer Vi squared to the other side. So that's negative Vi squared is equal to 2a delta y. So that's negative Vi squared over 2a is equal to delta y. Okay, and what are the values? So that's negative Vi squared. Vi is 26.2 times 2 all over, or 2 times a, which is negative 9.8 meters per second squared. I forgot the units at the top. It's meters per second. Now, units first. Okay, the units, m cancels out. The seconds, the one at the top cancels out. The one at the bottom only cancels out with a square. So that becomes a unit of meters per, or rather, seconds. Right? Oh, sorry. This is meters per second, and you square the entire thing. So in terms of units, that's meters squared over second squared. And at the bottom, you have meter per second squared. The seconds will cancel out. The meters, well, one remains at the very top. So you have meters. Sorry about that. Okay. Now let's get the values on. So that's negative 26.2 squared all over 2 times negative 9.8. Okay? And this will give you a value of 35.022. Okay? Now, for answer, let's check for sig figs. None. We can't get anything here. This one has 3 sig figs. This one doesn't count. Therefore, answer has 3 sig figs. Answer is then 35.0 meters. Delta y. Okay? So, this is an example of case 3. Now, let's go into the other case, which is also case 3, but it's a little different. So, in case 3b, it's kind of, it goes up, then down again. Okay? It's like you're shooting a basketball. At this part of your, let's divide this flight into 2. This part, throwing the object upward, is actually case 3. The second bit, falling from a velocity of 0, this is case 1. So to analyze problems like this, we can just simply look at 3 or one of these cases. Okay? And in this case, we also have to remember that hang time is equal to T up plus T down, which is simply 2T up or 2T down, because why? T up is equal to T down if they land at the same spot. Okay? Okay, let's check the problem. A baseball is popped straight up into the air and has a hang time of 6.25 seconds. Determine the height to which the ball rises before it reaches its peak. Okay? So what are we given? Pop straight up. Has a hang time of 6.25 seconds. Determine the height to which the ball rises before it reaches its peak. Okay, so given and required. So it goes up, then down. Hang time is 6.25 seconds. Okay, we know that the velocity at the top is equal to 0. And we also know that we have an acceleration of negative 9.8 meters per second squared. We're trying to find delta y, which is the height to which the ball rises before it reaches the very peak. Okay? So how do we do this? The first thing we can do is break up hang time. Divide hang time by 2, which will give you t up or t down. Okay? So if we break up hang time, 6.25 divided by 2 gives me 3.125 seconds. Okay? And remember, we're going to use 3.125 seconds. However, we still use the 3 sig figs of 6.25 because that's what you're given in the problem. Okay? So now we have velocity top and these three. What equation can we then use? Well, first we'll have to pick which case we'd like to analyze. Okay? So determine the height at which the ball rises. Let's use case 3. Why case 3? Because it's about determining the height before reaching the peak. Okay? So if that's the case, then V top would then be equal to your V final because that's going to the peak. That's your V final. So which equation has all of these attributes? Vf, delta y, A, and time. Which equation would have all of these? Well, actually, we can use a different kind of approach. We can also use the case 1 approach. Why? Because they are actually equal. Okay, they're solving for the same delta y. So this can also equal to Vi, okay, is equal to 0, right? And when you have that, we can then use the equation delta y is equal to Vit plus 1/2 At squared. Okay, let's check. Do we have a delta y? So delta y is question mark. Do we have a Vi? Yes, it's 0. 1/2 A t. We can solve. So it's just going to be simply 1/2 times A, which is negative 9.8 meters per second squared, times the time, which is 3.125 seconds. Okay, plugging into the calculator, we have 1/2 times negative 9.8 times 3.125. That's going to be equal to negative 15.3125 meters. However, this is where we go back to the original problem. Determine the height to which the ball rises before it reaches its peak. If you're going ball rising before it reaches its peak, so delta y in the going up is then what? If you're going up, this is a positive direction. Therefore, your delta y has to be positive as well. So the final answer would then be delta y is equal to positive 15 point, how many sig figs? Remember, we will count only the ones in the problem, 3 sig figs, okay? 15.3 meters positive. Okay, so this is case 3b, which means going up and then going down. The best way to think about it would be, think about a basketball. When you're taking a shot, it goes up, and then it slows down as you go to the very top, and then as you go down, it curves down back again like a parabola. Okay, so I hope this video was enlightening in solving problems related to free fall. If you have any questions, please feel free to ask them to me online or in person before our quiz. So take care, everybody, and good luck.